Hello and a warm welcome to you. Um, Today's video is not the one that I'd originally planned to publish. I'd originally planned a video that was a compilation of the 8 different proofs that the Earth cannot be flat that I've obtained by taking a few photographs and videos from a couple of locations in East Lothian in Scotland. However, while I was compiling the information for that video, I came across 2 more examples, possibly even a third example, that proves the Earth cannot be flat. And so I thought I'd share those with you today and make a compilation video of all 10 or 11 of these proofs later on. So you will not be at all surprised to hear that it is impossible to take this picture on a flat Earth. Clearly, it's possible to take this picture because I've taken it. And anybody else can go to the Hopetoun Monument on Byres Hill in East Lothian in Scotland and take the picture for themselves. It's not photoshopped, it's not altered, it is simply a picture, a still frame captured from a video shot from the top of the Hopetoun Monument in East Lothian in Scotland on a fairly clear day. Those of you who understand geometry and know a little bit about the area will understand why this proves the Earth cannot be flat. But I'll take some time to explain to everybody exactly why this proves the Earth cannot be flat. And in the course of that, we'll see another 1, possibly 2, further proofs the Earth cannot be flat. So I've taken that particular still frame and just adjusted the levels a little bit, just to sharpen it up slightly. The camera was at the top of the Hopetoun Monument at 210 meters. In the middle of the screen, you can see the Bass Rock. This is an island, an old volcanic plug, a bird sanctuary in the Forth Estuary, just off the coast near North Berwick. It's 107 meters at the highest point above sea level, and it is 14.91 kilometers from the camera, according to Google Earth. The calculated distance to the horizon on a spherical Earth is between roughly 52 and 56 kilometers. You can see that we have a nice, sharp, straight horizon, exactly as you would expect on a spherical Earth. You would not expect such a clear, crisp, sharp horizon on a flat Earth, but that's not really the point of today's video. If we zoom in slightly on the Bass Rock, you can see that the top of the Bass Rock appears just above the horizon. Not by very much, but just above the horizon. Now, why does this prove that the Earth cannot be flat? Well, the key thing here is the geometry. The camera is at 210 meters, the Bass Rock at 107. We're looking down at an angle towards the top of the Bass Rock. And on a flat Earth, we should be able to see water beyond the Bass Rock, rising up in our field of view to whatever horizon there would be on a flat Earth. However, in reality, what we see is that the horizon is below the level of the top of the Bass Rock by just a small amount, and that is not possible on a flat Earth and is possible on a spherical Earth. In fact, it's exactly what we would predict on a spherical Earth. So let's look at the predictions for a flat Earth and a spherical Earth in Walter Bislin's curvature calculator. Putting in the appropriate figures for size and distance from the camera, the flat Earth is shown on the left here. The Bass Rock, as you can see, the top of the Bass Rock should be well below the horizon. Wherever the horizon might be in this view here. So eye level here and the horizon are indicating effectively infinity. And clearly we can't see to infinity. But we certainly can and should be able to see all of this water here back at least 50 kilometers from the camera, probably quite a lot further. The spherical Earth has the top of the Bass Rock just poking above the horizon. That's the prediction, and that's what we see in reality. So the spherical Earth prediction matches reality exactly, and the flat Earth prediction is completely different to what we observe in reality. If we look at the observation from a side view diagram, we can illustrate this point. On a flat Earth, we would expect to be able to see water that was 24.1 kilometers beyond the Bass Rock. Sorry, 24.1 kilometers from the camera, probably about 10 kilometers from the Bass Rock. Anything beyond that point should appear above the Bass Rock in our field of view. And I'll show you shortly that we can definitely see plenty of this water, this distance in our image, even though it's not on a flat Earth. On a spherical Earth, we'd expect the horizon to be at around 52 kilometers, as I showed earlier, and indeed that matches very well what we see in our scale diagram. If any of you are concerned about the line not lining up here, if we zoom in, you'll see that it's just the way the screen is presenting the image. And if you zoom in, it does sit on the top of the Hopeton Monument triangle. In an effort to prove that we should be able to see water above the Bass Rock in our original image, I went a few frames earlier in the video and found this image of the Isle of May and North Berwick Law. Again, I've sharpened that up a little bit. This picture of the Isle of May serves as another proof that the Earth is not flat, very similar to one that I published viewing the Isle of May from Traprain Law. But before discussing that, I want to explain why this demonstrates that we should be able to see water above the Bass Rock if the Earth is indeed flat. The Isle of May is 27.6 kilometers from the camera. That is actually to the lighthouse. The water we can see here is 27.6 kilometers or more from the camera. And we saw just a moment or two ago that any water that is beyond 24 kilometers from the camera should be visible above the Isle of May if we can see that far. Well, clearly we can see much, much further than 27.6 kilometers. So there is no reason on a flat Earth why we should not see water above the Bass Rock. That arrow indicates the focal height of the lighthouse. This indicates the height of Berwick Law, and we'll look at those later. And this is the horizon on a spherical Earth. So just to go over that point again, on a flat Earth, the point on the water that should coincide with the top of the Bass Rock is 24.1 kilometers away. So some flat earthers in a previous video of mine argued that the horizon could be at that distance. It could be 24.1 kilometers, and the atmospheric conditions are such that we simply cannot see beyond 24.1 kilometers. It seemed to be an incorrect statement. I had evidence that I could see at least 90 kilometers on that particular day, but let's consider this possibility. The possibility that the horizon is really at 24.1 kilometers. And we can't see anything beyond that. Well, if that was true, we wouldn't be able to see the Isle of May. And we should see a horizon line here and sky beyond it. Clearly, we see the Isle of May, and we see plenty of water extending beyond that point. All of that should appear above the Bass Rock if the Earth was indeed flat. As I said at the start, the top image here of the Bass Rock is impossible to take on a flat Earth. Now, if you think you can explain how the horizon can be lower than the top of the Bass Rock in this image, then please let me know. You can post it in the comments. I'll put my email address and you can get in touch with me by email if you'd rather do it that way. I'd like to hear some explanations, but please try to make them sensible and not invoke magic. This diagram from Walter Bislin's calculator is to indicate where a 52-kilometer horizon would be on a flat Earth. So this marker here is placed 52 kilometers from the observer at 210 meters. This is where the Bass Rock should be, and this is where horizon would be if it was 52 kilometers away, as we calculate it to be for a spherical Earth. Now let's look at the Isle of May. I've previously published a video from Traprain Law showing just the very tip of the lighthouse tower being above the horizon and asking how that is possible with the camera at 210 or 221 meters, looking down at the 73-meter focal height of that lighthouse. Now we have a very similar image taken from the Hopeton Monument. Because I'm a little bit further away at the Hopeton Monument, the angle that we're looking down at is slightly different. And so we now have the majority of the lighthouse building actually above the horizon. This is also impossible on a flat Earth, as we shall see shortly by looking at predictions from Walter Bislin's calculator. It's also true that Berwick Law at 187 meters is below the height of the camera at 221 meters. And therefore, we should really be able to see water above the top of Berwick Law. But because of the very shallow angle that we're looking down on Berwick Law, we would have to see a very long way into the distance to be able to see that. And I'm prepared to accept the flat earther argument in this particular case, that we simply couldn't see far enough to come to any firm conclusion about whether the Berwick law observation proves the Earth is not flat or not. So what do we predict using Walter's calculator? Well, the Isle of May from the Hopeton Monument should look like this. On a flat Earth, we should still be able to see lots of water above the island in our field of view. On a spherical Earth, we should see quite a significant portion of the island plus the lighthouse. In this case, what we see is the majority of the lighthouse building. I think that's 23 meters tall, that lighthouse building, and we probably see about 20 meters of it above the horizon. And that's exactly matched by Walter's prediction, or his calculator's prediction. This shows where the 52-kilometer horizon should be on the Isle of May picture. And just for completeness, this is what the curvature calculator predicts for Berwick law. On a flat Earth, it predicts that we should still see the water above the top of Berwick law. But admittedly, that water is going to be a long way in the distance. I haven't worked out how far this particular line is from the camera, but it's quite a long distance. However, the prediction from the spherical Earth model is exactly the same as we observe in reality, with a significant portion of Berwick law appearing above the horizon, as you see in the bottom half of this image here. Once again, the observation we make matches perfectly what we should see on a spherical Earth, and is completely different to what is predicted on a flat Earth. If I can give you a sort of analogy and explain how science works and why we disprove things and then discard them when they are disproved. In science, you make a hypothesis. You might make the hypothesis that the speed of light is 100 kilometers per hour. And you might be able to test this by placing a light, a very bright light, 100 kilometers away from an observer. And at a distinct time, known by the observer, the light can be switched on, and that's verified by people close to it. Now, if the speed of light really was 100 kilometers per hour, the observer would actually see the light being switched on 1 hour later than it actually was switched on. And that would confirm the hypothesis, but not prove it true. However, what would happen in reality is that the observer would see the light being switched on almost instantaneously, almost at exactly the same time as it was actually switched on. This would mean that our hypothesis that the speed of light is 100 kilometers per hour can be rejected. We have proved that that is not true. And then we form a new hypothesis. We might say, well, it's a lot faster than 100 kilometers an hour. Maybe it's 10,000 kilometers an hour, and so on. And by doing careful measurements, we can actually, and have actually, measured the speed of light. And we know exactly what that speed is. I can't remember it off the top of my head. I wish I could. The same applies here with these observations. The hypothesis is that the Earth is flat, and that makes definite predictions about where the horizon should be in relation to the top of the Bass Rock and the top of the Isle of May and the lighthouse on the Isle of May, and even makes predictions about where it should be in relation to Berwick Law. By taking photographs or video clips, we test that hypothesis. And when we see that what we observe in reality is completely different to what our flat Earth hypothesis predicts, we reject the hypothesis. We say it has been proven to be false, untrue. And that applies unless someone can come up with an explanation which allows the flat Earth hypothesis to predict what we actually see in reality. So, flat earthers, what you need to do is come up with a flat Earth model or flat Earth explanation that predicts this observation of the Bass Rock, with the horizon lower than or possibly just level with the top of the Bass Rock as viewed from the Hopeton Monument in East Lothian. That explanation must also explain exactly how the horizon can be lower than the top of the lighthouse when viewed from the Hopeton Monument in East Lothian on a flat Earth. It's no good having one set of geometry and one set of explanation that explains the Bass Rock observation if it does not also explain the Isle of May observation. And for good measure, it needs to explain the Isle of May observation from Traprain Law that I published a few weeks ago. And for good measure again, it needs to explain all of the other observations that I've made from Traprain Law and from the Hopeton Monument in East Lothian, and a whole bunch of other stuff as well that mankind has known for centuries, even millennia. Well, let's start with these observations, these two. Can you come up with an explanation that explains both of these observations in terms of a flat Earth? Please get in touch if you think you can. And if you can't, please consider the very strong likelihood that the Earth is not flat.